Welcome back for another lesson in Math 8. Today we're in Unit 5, Lesson 15. We're talking about the volume of a cone. In today's lesson, we're going to learn about how to actually find the volume of a cone. And we're going to do that by actually comparing the cone to a cylinder. So we've learned about cylinders, and we've learned specifically that the formula for a cylinder is going to be the area of the base, the circle, pi times radius squared, multiplied by the height. So the question that comes down to is this: the cone and the cylinder have the same height and the radii of their bases are equal. So this radius and this radius are the same, the heights are exactly the same. Which figure do you think has a larger volume? Now, if you said the cylinder, you'd absolutely be right. Given the values that we have, do you think the volume of the smaller one, of the cone, is more or less than 1/2 the volume of the larger one? Make a decision, see what you come up with, write something down here, please. And then we'll explain that here in a few minutes. Quick method for thinking about how to sketch a cone. Start with the base, just draw an oval, draw a point at the center above that oval, so straight up above, somewhere above the center. It might also be helpful for you to put a point right there in the middle. Connect the edges of the oval, so this edge right here, to that point up above. And the reason for this center point is just to help us to figure out where the height of this would be. And when we're talking about these pieces, which part is actually hidden? The part that's hidden is this line right here. There's a couple pieces that we need to recognize that when we're talking about the height, we're talking about from the tip of the cone down to the center of the base. So there's our height. Our radius is from the center to one edge, just like in a normal circle. And then there's this other side over here. This is called the slant height. That's not something that we're really going to be working with in 8th grade, but it is something you'll work with in geometry when you get into high school. So that slant height is something, we'll touch on it in when we talk about Pythagorean theorem, but that's not for today's discussion. You can go ahead and get some practice sketching different size cones right here. Remember, cones, the base doesn't have to be on the bottom. Okay. When we work with this, we talk about from cylinders to cones. So we're going to be making a transition and using the formal volume of a cylinder to figure out what a cone is. To be able to do this, what we need to recognize first and foremost is that the bases of cones and cylinders are the exact same shape. They also have a height factor that's exactly the same type of situation, but there's one thing that's different. If the volume of the cylinder is 90 cubic centimeters, so right here, the base is exactly the same, the height is exactly the same. There's just one thing that we need to be aware of. If I were to take this cone, let's say if I took this cone and flipped it upside down and set it inside of this cylinder, this edge right here would rest on the top, or perhaps if this was open and I set it on here, how much of this space, the volume, would actually be filled up by that cone? I'd like for you to make a prediction. Thanks for doing that. And now what we can do with that is understand this, that the cone with the same radius and the same height will fill up 1/3 of the volume of that cylinder. So in this case, what we're after is that the volume of the cylinder is 90 centimeters cubed. What's the volume of the cone? Well, if we take that, we go 90 divided by 3, we end up with 30. And so the volume of the cone is equal to 30 cubic centimeters. And if we're talking about the volume of a cone is 120 cubic centimeters, we want to take that 120 and divide it by 3, which means that we're going to get 40 cubic centimeters. So the volume of the cone would be 40 cubic centimeters, right? So if the volume of a cylinder is given as volume is equal to the area of the base, which is a circle, pi times the radius squared, what is the volume of the cone? We can either write an expression for the cone or explain the relationship in words. I'm going to do both. The formal definition would be volume is equal to 1/3 the area of the base times the height, or simply 1/3. You could say volume of a cone is 1/3 that of a cylinder with equal radius and height. There you go. So now that we know that formal definition, we are going to use this formula, and we're going to use a lot of substitution to figure out the areas that we're working with here. We are going to continue to compare it to a cylinder as well. So here's a cylinder and a cone that have the same height and the same base area. What is the volume of each figure? Express your answer in terms of pi. Remember, in terms of pi means we are not going to approximate to 3 1400ths. We will leave pi as pi, which actually makes it kind of nice. So we know the height of the cylinder is 4. That means the height of the cone is 4. We know the diameter of the cylinder is 10, so the diameter of this cylinder is 10. But we have to remember it's the radius that we're after, so that makes the radius 5. Now all that's left to do is find the volumes. We'll start with the volume of the cylinder. Volume is equal to pi times the radius. I'll go ahead and put these up here. Volume is equal to pi times the radius squared times h. And then for the cone, volume is equal to 1/3 the volume of the cylinder. I guess it probably would have made sense to put that formula right here, but we're going to go ahead and go like this. The radius is 5. We're going to square that, and then we'll multiply it by the height of 4. So the volume is equal to 5 times 5 is 25. 25 times 4 is 100. And then we'd simply multiply that by pi. And then we could say that this is cubic units, or units to the 3rd power. Now what that would end up looking like as far as the next step to find the volume of the cone, the cool thing is I know the volume of the cylinder, which means that the volume of the cone would just be 1/3 that of the cylinder. I can see this in 2 ways. Number one, I can go like this. The volume is equal to pi times the radius, 5 squared, times the height of 4. But keep in mind, as a cone, that cone is 1/3 the total volume of a cylinder. So what I would have to do with this is the volume would be equal to 100 times pi. I'm going to leave this as thirds because it's a precise value. It would mean that I'm not going to have to go ahead and round it off to 33 3/10 or 33 1/3. I guess I would accept that, 33 1/3 times pi, but this is the preferred value for that answer. If I'm given here a cone, it says, what is the area of the base? Well, we know the area of the base is a circle, and so the area of the base would be equal to pi times the radius of 6 raised to the 2nd power, so pi times r squared. Area of circle is pi times the radius squared. And so when I substitute that and answer in terms of pi, all I have to do is take 6 squared, which is 6 times 6. So the area of the base would be 36 times pi. In this case, there's no unit given, so we just say units squared. What is the volume of the cone? Express your answer in terms of pi. As I take this value, I take the volume, I know the base, capital B, big base, so my area is going to be 1/3 of that base, pi r squared, which we've already found right here, 1/3 of 36 times pi. And now I need to also multiply by the height of 8. So if I work through this, I take 1/3 of the base area of the base times the height. That's going to be 1/3 of 36 is 12 times pi. And 12 times 8 is 96. times pi units, in this case, to the third power, because now I don't know why I did area. This is volume, because now we're talking about a three-dimensional figure that is now no longer just flat like area, but it has some height to it. So imagine for a minute a cone-shaped popcorn cup has a radius of 5 centimeters and a height of 9 centimeters. How many cubic centimeters of popcorn can the cup hold? Use 3 1400ths as an approximation for pi and give a numerical answer. So in this case, obviously what it says, numerical answer, we are going to see where that comes up. Let's first set things up. We know that the volume is unknown. We know that we have pi, which is not going to be pi this time. We'll put it in there as 3 1400ths times the radius squared, which is 5 squared, times the height of 9. So again, the volume is equal to 1/3 pi times the radius squared times the height. And so you might be saying, well, where do you have the 1/3? Given this situation where it's at, I can actually put, since this is all multiplication, I can put that 1/3 and these values in any order. And what I'm going to do is something just a little bit different. I'm going to actually, rather than multiplying by 1/3, because I have a very simple calculator here, is I'm going to just divide by 3. So I'm going to do 3 1400ths times 25. Then I'll multiply that number by 9 for the height, and then I will divide that value by 3. And I get the total volume of 235.5 centimeters to the third power. There we go. Quick as that, simple as that. If you're ready for more, you can give this one a shot. You've got a grain silo that has a cone-shaped spout at the bottom in order to regulate the flow of grain out of the silo. The diameter is a silo of 8 feet. The height of the cylindrical part of the silo above the cone spout is 12 feet, while the height of the entire silo is 16 feet. Here's a drawing of that image. We'll let you go ahead and work that one out. But I will give you this piece of it says how many cubic feet of grain are held in the cone portion. Well, really all you have to do is consider just that cone and figure out the height from there. If the cylinder is 12 feet, the height of the entire thing is 16 feet. Consider that height from here to here. What's the difference between that 12 and that 16? After you're done, you need to figure out how much grain the entire silo would hold. I would highly, highly, highly recommend you spend some time working on this one, because it might just come back up someday. That's the end of our lesson today, folks. Today, the thing we have to absolutely remember about all this, cones and cylinders are very, very similar. In fact, a cone can be made from a cylinder by taking a diagonal cut and just rolling the edge into a slant edge. The fact is that when we have a cone and a cylinder with the equal radius and an equal height, the cone will be 1/3 the volume of the cylinder. So when we talk about a cylinder that has a volume of 63 times pi cubic feet, we found that by taking pi times the radius squared times the height. The cone just has 1/3 of that volume. So if I take the total volume of that cylinder of equal radii and height, then 1/3 of 63 is 21. So if the radius for both is r and the height is both h, then the volume of the cylinder is given like this. That means the volume of the cone is just simply 1/3 the volume of the cylinder. That's it for today's lesson. Thanks for tuning in. Make sure you go and get the homework done, and then let me know if I can help with any other questions. Have a great day.